Alright, and we are starting. Just posting the link to Discord. Alright, let's get started with the quiz. Alright, 3-wire single-phase systems are used because this type of system provides 240 volts. Yes, that's why we do it, so you can have 120 and 240 in a household. Your two lines each have 120 volts across them, and they were 180 degrees apart from each other. So if you measure between the two of them, you get 240 volts. You could say one is at positive 120 volts and one is at negative 120 volts. And since voltage is a difference of potential, the difference of potential between the two of them is 240 volts. Next up, in a 3-wire single-phase system, what is the maximum unbalanced load the neutral conductor must be able to carry? The full load of either leg. So yeah, maximum unbalanced load is the full load of either leg. So you can't downsize your neutral if you are sharing your neutral. But you do not need to upsize your neutral for sharing your neutral in a normal 3-wire single-phase system. Yeah. There are some situations where the current will not be negated on the neutral, but we'll talk about that in a little bit. How much current flows on the neutral in a balanced 3-wire system? Since it's balanced, the way that currents work in a 3-wire system is that since you're sharing the neutral, one would be at, let's go to paint. So let's grab that. Let's use gray. Oh no, I want that one black. And then let's do red for the third one. So let's say we have, let's use green. Oh. Shoot. We got red. Okay, that's the right order of doing things. So let's say we have 2 amps and 2 amps. You could say that this is actually negative 2 amps because it is 180 degrees out of phase with the black wire. Whenever they come onto the neutral, you will actually read 0 amps because they will cancel each other out. But let's say this was 12 amps and negative 2 amps. Well, you're not going to cancel out completely, so you'll have 10 amps left. That's a very simplistic way of explaining it, but let's move on. In a 3-wire single-phase system, line-to-line voltage is blank and line-to-neutral voltage is blank. 3-wire single-phase system, line-to-line voltage is 240. What we got? Yes, 240, 120. This is a basic 3-wire single-phase system. This is your house. Moving along. Neutral of an unbalanced 3-wire system is open. The circuit becomes a 240 volt series circuit. Since the line with the smaller load has higher resistance, more than half the total voltage drops across it. Since a series circuit, the one with the higher resistance will get more voltage. We saw that in the last lessons. Alright. Okay, we already covered this one, the full load of either leg. What is the disadvantage of a 3-wire single-phase system? What is the disadvantage? So the disadvantage would be open neutral could damage equipment. Because if you lose your neutral, you will get higher voltage than 120 volts. And that could burn things up. And then on the other side, you will have a lower voltage on the other stuff, which could also damage some equipment. What would the voltage be across R5 for the circuit shown in the figure below if the neutral were opened at point A? Alright, so let's open up paint. So let's resize. Alright, so the neutral is opening up at point A. So all of this is gone. So essentially what that's made this circuit is so you don't have a neutral at all anymore. So this is the circuit you're working with. You can take all of this. Since it's just 120 volts and 120 volts in series, you can turn that into okay. So now we have this circuit. You might, if you delete this over here, you might recognize this from some of the combination circuit lessons. I don't know what the question was, so let's look at what the question was. What would be the voltage across R5? R5's right there. For the circuit shown in the figure below if the neutral are opened at point A. So I can tell you it's not 120 or 240. So that leaves you with 60 and 92. So let's expand our play area. Alright. So we have two sets of parallel circuits. R1 and R2 are in parallel with each other, and R4 and R5 are in parallel with each other. So let's open up 40 to -1 plus 60 to -1. Close it, one more -1. And down here, 20 plus 60. All right. There we go. So let's open our parentheses and do, I've talked y'all through this 100 times. So the top one is 24. And while we're at it, let's just go ahead and open parentheses. $24 and $15. All right. So now we have a series circuit essentially. And that circuit looks like this. 240 volts. Got 124 ohm resistor and another 16 ohms. All right, so we got these two circuits. That's what, 40 ohms our total. All we're looking for is this voltage, E of 4 comma 5, because since they're in parallel, they're going to have the same voltage. So I'm gonna delete this just to give myself some room. You guys have seen it over and over and over again. So we know R1, yeah. Our total, is 40 ohms. Because series circuit, you should be able to do those in your sleep. R1 comma 2 is 24 ohms, and R3 comma 4 is 16 ohms. Now, without doing any more math, I can tell you the answer. It has the lower resistance. Based on our last current voltage divider lesson, it's in series and it has the lower resistance. That means it's going to have the lower voltage. We've narrowed it down to just 2 voltages. It's 60.45 is the answer. What happened? R5. What did I do wrong? Show an explanation. 24 and 15, got that. Did I write 16? I mean, that doesn't change what my assumption was. 39, and they did. And they do the it's the I don't know. It should. It has the lower ohm. I'm gonna finish the math. I don't agree. But it is 15, not 16. Alright. The total is 240. Now you'll notice that I'm ignoring R3, and that's because it's not affecting any of the math here. It's its own parallel leg. It gets a whole 240 volts. Oh, 60 isn't the other option. Alright, so they are, okay, first we need to find our current. $240 divided by 40 will give us our current. It's 6. Six amps, and that's going to be 6 amps and 6 amps. So all we need to do is 15 times 6 is 90. And that will give us what? 130? No, that's not right. Let's do the math. 144. 144 volts. And that's pretty close to adding up. I'm sure I skipped some decimals in a few spots. But yeah, so there's 90. So 60 was never on the table as an answer. So we weren't choosing between 60 and 92. It was just 60 was never possible. 3 never possibles, and then 92.3. All right, and that will finish up this lesson. So I will talk to you guys later. Let me close out this. Let me know if you guys have any questions while you're working through stuff. And I will, right after I take this down, I'm going to put up a review with all the questions we did today. All right, see you guys later.